I'm sure you've heard the news, fusion energy just leveled up. This isn't just another headline or a small step forward. What happened at the Wendelstein 7X fusion reactor in Germany is a massive leap for science, and it could change the way we power our world forever. For decades, scientists have been chasing the dream of harnessing the same energy that powers the sun and the stars, nuclear fusion. It's been called the holy grail of energy, and for good reason. Imagine a world where we have access to nearly limitless clean energy with no greenhouse gases, no long-lived radioactive waste, and no risk of catastrophic meltdown. That's the promise of fusion. And today, we're closer than ever before. Germany's Wendelstein 7X just shattered a record scientists have chased for decades. This isn't just a small improvement, it's a breakthrough that's making headlines around the world. The Wendelstein 7X, or W7X for short, is a type of fusion reactor called a stellarator, and it's been quietly pushing the boundaries of what's possible in fusion research. But what exactly did they achieve, and why is everyone so excited? But what does that actually mean for you and me? So, what's the Wendelstein 7X? Let's break it down. Most of us have heard about fusion in science class or maybe in sci-fi movies, but the details can get pretty technical. The Wendelstein 7X is a machine designed to test whether we can create and control the conditions needed for fusion here on Earth. It's not about making electricity just yet. It's about proving that we can tame the power of the stars. Imagine a donut. Now twist it like a pretzel, supercharge it with magnets, and try to trap mini sun plasma inside. That's basically what a stellarator is. A mind-bendingly complex machine that uses powerful magnetic fields to confine a super-hot, electrically charged gas called plasma. This plasma is where fusion happens, and it needs to be hotter than the core of the sun, over 100 million degrees Celsius. The shape of the W7X isn't just for show. Its twisted, toroidal design is the result of decades of mathematical modeling and engineering, all aimed at keeping that plasma stable and contained for as long as possible. That's basically W7X, a fusion reactor in Germany aiming to master something called the triple product, the magic recipe for making fusion work. The triple product is a kind of scorecard for fusion reactors. It combines three crucial ingredients: the temperature of the plasma, the density of the plasma, and how long you can keep it all together. If you can get all three high enough, for long enough, you can achieve what's called ignition, the point where fusion reactions become self-sustaining and produce more energy than you put in. It's the ultimate goal, and it's incredibly hard to do. Now, the triple product is like trying to juggle three flaming torches on a unicycle in a hurricane. You have to keep the plasma hot enough, dense enough, and stable enough, all at the same time. If any one of those things slips, the whole process falls apart. It's a balancing act that's pushed the limits of science and engineering for over half a century, and every time we push those limits a little further, we get closer to unlocking a new era of energy. You need super hot temperatures, high pressure, and to hold that plasma steady, all at once. The plasma inside W7X is hotter than anything else on Earth, and it's held in place by some of the most powerful magnets ever built. These magnets are cooled to near absolute zero, and they create a magnetic cage that keeps the plasma from touching the walls of the reactor. If the plasma touches the walls, it cools down instantly and the fusion reaction stops. So the challenge is to keep that plasma floating, spinning, and burning without letting it escape. If you pull it off, you're basically cooking up star power. That's right, the same process that lights up the sun and every star in the night sky is happening for a few precious seconds right here on Earth. It's a mind-blowing achievement, and it's taken thousands of scientists, engineers, and technicians working together for decades to get this far. The Wendelstein 7X is a testament to human ingenuity and our relentless drive to solve the world's biggest challenges. Here's the exciting bit. Wendelstein 7X just hit a triple product over 1.3 times 10 to the 21st. That number might sound abstract, but in the world of fusion, it's a huge deal. It means that W7X has achieved a combination of temperature, density, and confinement time that puts it among the very best fusion experiments ever conducted. This isn't just a small step forward, it's a leap that's setting new benchmarks for the entire field. For context, that's twice its previous best and right up there with the world's top reactors. Only a handful of machines on the planet have ever come close to these numbers, and most of them are tokamaks, a different type of fusion reactor. The fact that a stellarator like W7X is now competing at this level is a game changer. It shows that there's more than one path to fusion, and that the future of energy could be even brighter than we imagined. Plus, it kept plasma stable for over 8 seconds, which is an eternity in fusion world. To put that in perspective, most fusion experiments struggle to keep plasma stable for even a fraction of a second. 8 seconds might not sound like much, but in the world of fusion, it's a marathon. It means that the W7X is not just reaching record numbers, it's doing it in a way that's sustainable and repeatable. That's a critical step toward making fusion a practical source of energy. This doesn't mean we'll have fusion power plants next week. There's still a long road ahead. Turning these experimental results into a working power plant will take years of research, development, and investment. There are still technical challenges to overcome, and we need to figure out how to make fusion not just possible, but affordable and reliable. But make no mistake, this is a giant leap forward, and it's bringing the dream of fusion energy closer to reality. But it's a giant leap toward clean, nearly limitless energy. Imagine a world where our cities are powered by the same process that fuels the stars. No more dependence on fossil fuels, no more air pollution, and no more worries about running out of energy. Fusion could provide enough power for everyone on the planet with minimal impact on the environment. It's the ultimate clean energy source, and breakthroughs like this are making it possible. Is this science fiction or the future of energy? For decades, fusion has been the stuff of dreams and science fiction. But today, it's becoming science fact. The progress at Wendelstein 7X is proof that we're not just imagining the future, we're building it, one experiment at a time. The next generation of scientists and engineers will take these breakthroughs even further, and one day, fusion power could be as common as solar panels or wind turbines. Let me know what you think in the comments, and don't forget to subscribe for more wild science breakthroughs. Are you excited about the future of fusion energy? Do you think we'll see fusion power in our lifetimes? Or do you have questions about how it all works? Drop your thoughts below, and let's keep the conversation going. The journey to fusion is one of the most exciting stories in science, and together we can witness history in the making.